Good morning, everyone. My name is Dr. Himanshu Sharma, and I am head of the HOD, head of the department of Department of Electrical and Electronic Engineering. I am going to explain you in this topic about ripple and arbitrary counters. So, first move to ripple and arbitrary counters. To learn about these counters, first of all, I would like to tell you that there are two kind of counters. First is ripple counter, and second is synchronous counter. As you can see on the screen, synchronous counter is that counter which actually all the flip-flops synchronize with each other, and ripple counter is that in which all the flip-flops are not synchronized with each others, right? So to learn this ripple flip-flop, I am going to explain you about this figure in which the flip-flops are mentioned, and clock is also mentioned, logic is also mentioned, and all the outputs also mentioned, which is Q0, Q1 and Q2. So in the ripple counter, the flip-flops output actually transmissions serve as a source for triggering other flip-flops. Like the second flip-flop, which you can see on the screen, is actually getting the output of first flip-flop, which is Q0, right? In other words, you can say that the clock inputs of the flip-flops are triggered by output transitions of other flip-flops rather than a common clock. So there is no common clock, so all the clock's inputs are actually coming from its previous flip-flops. So typically T type of flip-flop are used to build the ripple counter. As you know that there are four kind of flip-flops: JK flip-flop, SR flip-flop, T flip-flop, T flip-flop. So T flip-flop is we are using, and we have to use in the ripple counter, this ripple counter, right? So the signal with the pulse to be count, the signal which pulse to be count, that is the pulse is connected to clock input of the flip-flop that holds the least significant bit, right? The output of each flip-flop is connected to the clock input to of the next flip-flop in sequence, and the flip-flops are negatively edged. This is very important line, and all flip-flops are negatively edged. Bubble clock is actually as you can see the bubble clock in the input, so they are negatively edged, right? For T is equal to 1, and for all the flip-flop J is equal to K is equal to 1, it means T flip-flop means J and K are you are giving the same input for J and K. So this means that E flip-flop complements its value, as you can see